Hi everyone, I hope we are live, so you should be able to hear and see me. Uh, you can just comment in the chat box. You can say yes or no if you can hear me or not. Okay, so a lot of you are saying yes, I believe it's audible. Okay, awesome. So today's question is a great question. It's a very beautiful question. Did you get some time to read and understand the problem statement? You can just reply yes if you read and understood the problem statement. Okay, so just for everyone, I'm going to reiterate it. The problem basically says that we are going to have some sequences. Okay, so basically we are going to have a family of sequences, and these sequences are made up of zeros and ones. Okay, now the interesting thing about it is that the first sequence in this family is a simple 0. Okay, now the rule says that in every subsequent row, by row we mean in every subsequent sequence, we look at the previous row and replace each occurrence of 0 with 0 1 and each occurrence of 1 with 1 0. So in order to generate the next sequence, I have to look at the previous sequence, and in previous sequence wherever there is 0, I will want to replace that 0 by 0 1. So that's the first rule. Replace 0 by 0 1, and instead of 0 if you had a 1, then you got to replace 1 by 1 0. That's the rule. So yeah, when I'm looking at this string, I have got a 0, so I'll replace this 0 by 0 1, and that's all. I am done. So 0 1 is the next sequence in this family. Okay. Similarly, if we keep moving ahead, if we try to generate the next member, now we will look at this, and when we look at the first character, which is 0, we will want to replace it by 0 1, so we will place 0 1. And when we look at the next character, it is 1, so 1 should be replaced by 1 0, so now we will put 1 0. Similarly, you can go on generating the next member also. So if I have to generate the next member, again I'll say that this 0 may be replaced by 0 1, and this 1 may be replaced by 1 0. This 1 may also be replaced by 1 0, and this 0 may be replaced by 0 1. Yeah, so this is the rule for generating all the members of this family, correct? Now I can already see that a few of you are saying that you tried doing it with brute force and it didn't work out, right? Okay, so tell me one thing, a very simple thing. If I ask you that, hey, the length of previous string is L, then what will be the length of next string? Can you tell me the length of next string in terms of L? Yeah, it will be 2 into L. Common sense, right? Simple common sense. Because we all know that for each character of the previous string, we are going to generate two characters, because you are saying that 0 needs to be replaced by 0 1 and 1 needs to be replaced by 1 0. So of course, if there are 4 characters here, then there will be 8 characters here, and that is exactly what is the scene over here, correct? Now do you see a trend? By trend I mean, if I ask you that, hey, let's say there is nth subsequence and I want you to tell me the length, what will be the length of nth subsequence? Tell me that. Your answer should be in terms of n. So like, this is my first subsequence and its length is 1. This is my second subsequence, its length is 2. Here the length is 4. Here the length is 8. So 2 raised to power n minus 1, one of you is saying, and then there is saying 2 into n. Okay, let's think of it in this manner. If you look at this pattern, this sequence, how does it look? These are all different powers of 2, isn't it? This is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So I can say that the first member will be of length 2 power 0, the next member will be of length 2 power 1, the next member 2 power 2. So the nth member will be of length 2 power n minus 1. And this holds very well. Now think of it in this manner. If you look at the constraints, it says that n can be around 30. So roughly speaking, guys, I can say that in the worst case, my string could be of length 2 power 29, because if this is 30, it could be 2 power 29. Now, don't you think it is going to be a very huge string, right? I mean, this length is really going to be a lot, correct? Now, if you go after creating all the members of this family according to the brute force approach, so those of you who are speaking brute force approach, you would have done exactly this. You would have created each member from the previous member, each member from the previous member. Then that creation step would have taken time, because when you are generating long strings from the previous long strings, of course it would take time. That's the first thing. Okay, and further, the second thing is that it would also take a lot of memory, because in order to store those strings, you would end up consuming memory also, right? Is this point making sense to everyone, that why brute force will be inefficient? Because the sizes are exponential. So we will take a lot of time to generate those exponentially sized strings, and memory would also be consumed. So this is not an ideal approach. So we need to act smart. We need to think of something better. Okay. So yeah, anyone who was able to find some pattern inside this question, there is a beautiful pattern. Second half is complement of first. Okay, what do you mean by complement? By complement, usually people mean that you toggle the bits. I mean, you change 0 to 1 and 1 to 0, but that's not the case. Look here. When you say the second half, okay, you mean second half of the same string is the complement of first string. Okay, that's an interesting point. Here it goes like that, because here 0 1 1 0, its complement will be 1 0 0 1, and that is exactly what is the case here. Okay. Good. Somebody is suggesting recursion. See, one beautiful thing is that the members of this family are being generated recursively. What I mean by recursively is that if you know the previous one, you can generate the next one. If you know the current one, you can generate the next one, and so on and on and on. This is recursive formulation, that you know the previous formula, so you can generate the current formula, and then you can use it to generate the next formula, and that's how you can keep going on and on and on. Correct? Okay. Okay, great. So some of you have mentioned some useful stuffs. I think that is a valid point. But let me ask you one simple thing. Can somebody quickly tell me the next member? I mean, what will be the next member after this string? Can you guys type it in the chat box once? I mean, I want that because I want to use that as an example. Meanwhile, I am also doing 0 1 1 0 1 0 0 1 1 0 0 1 0 1 1 0. Yeah, I believe this should be the next one, which is of length 16. See guys, in this entire process that we are doing, what we are doing is that we are you can think of it in this manner, that there is a string that you have and you are probably encrypting it. How you are encrypting it is that you are converting each 0 into 0 1 and each 1 into 1 0. Okay, so I can say this is some encrypted form of string. Now can you go back from this string, which is, can you try to decrypt it? I'll say yes, of course I can decrypt it. How? By looking at the pairs of characters. Like here, when I see 0 1, I am dead sure that this 0 1 would have come because of 0, right? So inside the parent there must have been a 0, so I can replace this 0 1 by 0. Similarly, I can replace this 1 0 by 1. Similarly, I can replace this 1 0 also by 1, and I can replace this 0 1 by 0. If you keep on doing this process, this is what you will get. This is what you will get out of this. Now, if you keep repeating this, if you repeat this thing again, you can say that this 0 1 must have come out of 0. This 1 0 must have come out of 1. This 1 0 must have come out of 1, and that 0 1 would have come out of 0. And if you repeat it again, you can say this 0 1 again would have come out of 0, and this 1 0 would have come out of 1, and finally this 0 1 would have come out of 0. So do you see one interesting thing, that when you start decrypting a string, you will always go back to where you came from. Where you came from? You came from 0, so you will go back to 0 if you try to decrypt it. And this is going to be true for all the members of this family. Is it making sense? How many of you are able to properly digest this fact? Not a fact, but an observation. Yeah? Okay, awesome. Now that we understand this point, it opens a door of possibility for a solution. How? Let's think of it in this manner. See guys, we all know that the length of parent is half of the length of child. So if this length is 16, this length was 8, this was 4, this was 2, this was 1. This is how it was, right? Now, I can say one thing for sure, that because every member eventually is encrypted, is decrypted into 0, so I can say that, hey, this is nothing, this is some representation of 0 only. So every string ideally represents a 0, because if you converge it, you go back to 0, right? Now, if you look at the two halves of it, like this is the first half, and then the part that is not shaded is the second half. Now that I know that 0 is dismantled into 0 1, so can I say that this left half is a representation of 0 and this right half is a representation of 1? Can I say that? Of course I can say that. And see, you can relate to it, because when I was converging this string, here it came to 0 1. So what really happened is that this left half got converged to 0 and this right half got converged to 1. Yes, this is exactly what happened. I mean, even if you take this right half in complete isolation with you and then you try to converge it by replacing every 1 0 by 1 and every 0 1 by 0, you will get 1 for sure. So the point that I am trying to make over here is that the left half of your original string is representation of 0 and the right half of your original string is representation of what? Is the representation of 1. And why is it so? It is so because every string is a representation of 0, and we know that 0 dismantles as 0 1 and 1 dismantles as 1 0. Now you know, if you keep on applying this idea on and on and on, then you can formulate a recursive solution out of it. So as I told you, this left half is a representation of 0. So let me put a separator here. This is a representation of 0 and this is a representation of 1. Now if you look at this in isolation, let's look at it in isolation. Okay, I'll put brackets here. Forget about everything else, just look at it. We know that this represents 0, so can I say that its left half will be representing 0 and right half will be representing 1? Can I say that? Yes. Why? Because 0 dismantles as 0, 1. So guys, if I just put a separator here and if you widely open your eyes, you will end up realizing the fact that this thing, if you try to converge it, it will become 0, and this thing, if you try to converge it, it will become 1. Correct? Okay, great. Now let's say if you pick this right half, the right half of your original string, that was a representation of 1, and we all know that 1 dismantles as 1, 0. Does it mean that left half will be a representation of 1 and right half will be a representation of 0? Does it mean so? Yes. If I put a separator here and if I ask you to individually look at this left half, if you converge it, you will get nothing other than 1. Similarly, if you converge it, you will get nothing other than 0. So do you see what is happening? This part completely was representing 1 and its left half represents 1 and right half represents 0. This half was completely representing 0 and its left half represents 0 and its right half represents 1, and that is very, very consistent with the recursive formulation that we had here. Okay, please repeat. Do you first understand that every string that you have is a representation of 0? Because it comes out of 0, right? So this entire string was a representation of 0. Now 0 dismantles as 0, 1. See, when you were converging this string, you reached 0, 1. Why you reached 0, 1? Because this left half got converted to 0 and right half got converted to 1. So I can say that for every original string, the left half is 0 and the right half is 1. But now when you look at that individual string, what its left half will be and what its right half will be, it depends upon what that represents. So like here it represents 1, so its left half will be a representation of 1, because 1 disintegrates as 1 followed by 0. But because this was representing 0, so this left half was 0 and the right half was 1. Now you can go on stretching this idea on and on. So like when you look at this string, what does it represent? We all know it represents 1, right? And we know that 1 dismantles as 1, 0. So we all know that left half will be representing 1 and right half will be representing 0. And is that not true? Yes, because this 1, 0 is for 1 and 0, 1 is for 0. Similarly, this is a representation of 0 and we all know that its left half will be representing 0 and the right half will be representing 1, and that is exactly what the case is. So it's a recursive mental model that I have tried to convey you. Could you get that? How many of you could follow me on whatever I have stated so far? Yes or no? Yeah. Okay, so now if we note this idea, we can go on and our job should ideally be done. If you're wondering how, I would say it's super easy. Just think of it in this manner. All that you have to do is you have to find the kth character of nth string. Okay, how many characters are there in nth string? How many characters are there? 2 raised to the power n minus 1. Okay, So we can say, let us say that the position of first character is 1. So let's call it low index, which is 1. And the position of last character, it will be this value. Okay. Now every time what we can do is, we can find out a value mid, which is going to be low plus high by 2. See, when I am finding mid, then what is happening is that I am segregating this string into two parts. Okay, the first half is from low till mid, and the second half is from mid plus 1 till high. This very much looks like binary search. If you have learned binary search, you will relate a lot to it. It's not exactly a binary search, but the style of search is like that. Okay, so here you can, if you look at it, I am segregating it into two halves, the left half and the right half. Correct? Now, what will be represented by left half and what will be represented by right half? Can you tell that? Zero by left and 1 by right. Okay, is that true always? Just think of it. The answer is no. That's not true always, because it depends upon what your sequence is representing at that time. Okay, like when you talk about the overall sequence was representing 0. In that case, the left part will represent 0 and the right part will represent 1. Okay, but let's say you had considered this half. Let's say you were searching recursively on this half, and now this represents 1. Because it represents 1, its left half will represent 1 and right half will represent 0. So I am reiterating the same point again, that what your left will represent and what your right will represent depends upon what your current string or current sequence represents. Do you get the point? Yeah. Right? Okay, great. Now that we understand this point, the problem is almost solved. Why the problem is almost solved? Because what does your original strings represent? No matter whether it is your first string or second or 10th or 15th or 20th, what does your first string represent? Just tell me that. Your first string represents 0, correct? Now that your first string represents 0, let's say the value of n was 4, and that way your low would be 1 and your high would be 8, correct? Now let's say the value of k was 6. So as per what I have done here, what will you do? You will find mid. Your mid will be 1 plus 8 by 2, which is going to be 9 by 2, that is 4, correct? Now this k, will it lie in the right half or will it lie in the left half? Given that your mid is 4 and the value of k is 6, where will it lie? It will lie in the right half. Because it will lie in the right half, so you will change your search space to the right half. Whenever you change your search space to the right half, what do you change? You simply change your low. And how do you change your low? It becomes mid plus 1. And now because you are going to the right half and the current string was representing 0, so the right half will start to represent 1, correct? So if you look at this entire thing, I have to maintain few important variables. The first variable will be low, the second variable will be high, which represents the section of the subsequence that I am talking about. Okay, of course there will be a value k also, which is a part of your input, and then there will be a current representation also. So initially the current will be 0 because we all know that our input string is 0. But whenever you go to right or left, you have to change this value of current accordingly. Do you get the point? Now, when should we terminate? What will be termination condition? So think about it. Whenever your low and high become exactly same, let's say your low is also at this index and high is also at this index, then at that point of time, whatever is your current, that will be your answer, isn't it? Because if you are just pointing to that character, and if your current is 1, that means that that character itself is 1. On the other hand, if it is 0, then that character itself is 0. That's it. So our termination condition will be achieved when both low and high become equal to one another. Okay. In that case, whatever is the current, we will return that current. Okay. Thinking of iterative approach, you can list down your approach. Yeah, you can do it iteratively also. Whatever you can do recursively can be done iteratively. Okay. So if the logic is different, you can list down that logic, and if the logic is same, it's just iterative, then good. Yeah. Okay. Cool. So yeah, that was about it. Now all that we are left over with is the implementation part of it. See guys, if we implement it, I'll tell you one thing. Implementation is very easy. You will find out mid, and then you will compare the value of k with mid, and you will decide whether you should go to the right side or left side. Now my question to you is, if the value of current is 0, in that case, when you are going to left, then what is the new value of current? It's 0. And if you are going to right, then it is 1. Correct? Okay. If the value of your current is 1, in that case, if you are going left, then what is the value? 1. If you are going right, then what is the value? 0. It's an important point. You know why? Because 0 disintegrates as 0, 1. If you are wondering why in this, and 1 disintegrates as 1, 0. Now the important thing here is to note that if you are going to the left half, the value of current will not change. Like if you are going to the left half, and if the current was 1, it will continue to be 1. If it was 0, it will continue to be 0. But if you are going to the right half, the bit will toggle. If the current bit is 0, it will toggle to 1, and if it is 1, it will toggle to 0. Can you note this observation? It's a small observation, but because it will simplify the code, so I am stressing upon it. Now, you know, whenever you have to toggle zeros and ones, and let's say you have a value x that either represents 0 or 1, then the simplest way is you can simply write 1 minus x. Think of it. Because if x was 0, 1 minus x will be 1. And if x was 1, 1 minus x will be 0. So if I just have to toggle in between zeros and ones, all that I can do is 1 minus x, and I can pass that. So what I can do is, whenever I am going to the right half of my search space, I'll make a call for 1 minus current, because I know that whenever I go to right, the bit toggles. But whenever I am going to the left half, the bit remains the same. Okay, cool. So now let's see the code. I already have implemented it here for you. So if you look here, as I told you, we are going to have a nth member of this family, and the first character will be at index 1. Remember, here our indexing is from 1, not from 0. And the last character will be at 2 power n minus 1. And then I have invoked this method where I am passing low, high, the value k, and current. The most important thing is this current, which represents the representation of your current string, right? Now when you look at it, the first condition says that if L is exactly equals to H, If L and H are exactly the same, that means you have converged to the same character. And if you have converged to the same character, you just return that. Whatever is the value of current, you return that. Otherwise, what you do is you figure out your midpoint, okay, and then you compare your K with mid. If K is greater than mid, what does that mean? If K is greater than mid, that means you have to search in the right half. If you have to search in the right half, you go to the right half, which is from M plus 1 to H. And in that case, you need to toggle your bit. If your bit was current, it will now become 1 minus current. And if your K was smaller than or equal to mid, that means you have to search in the left half. If you search in the left half, then this is the search space and the value of current will remain exactly as it is. Simple approach, why complicated? I do not get that. I do not get your question. I don't find this code to be complicated at all. I mean, for me, it looks very, very simple. I'm not sure about how it looks to others. I think ideally it should be simple, isn't it? What do you say, guys? Does this code give you a complicated outlook of what we have talked about, or do you find it easy to relate with whatever we have discussed? The important point was to first get the logic, right? Now, a lot of times what happens with people is that they look at the solution and they have no clue of why that code works. What is the real idea behind that? So this much of ideation that we have done is the real gem, is the real diamond behind problem solving. This is to nothing, and this is nothing. You can find this code written anywhere. The real thing was this. Behind every yes and no and whatever we are doing, why we are doing, we should have a clear reasoning for that. Yeah. Okay, great. Yeah, so any other question? If you have any other approach, you can probably comment it in the chat box. Yeah, just comment it in the chat box. I think everyone will be able to look at it also, and then I'll also be able to go through your code or pseudo code, and I'll review your code and share my feedback on it. Okay. But what we'll first do is we'll talk about the time complexity of it. Yeah, anyone who would want to talk about the time complexity? How much time would it take? Yeah, all of you should share your approach. All of you can do that. But let's first quickly talk about the time complexity of this approach. Log of n, okay, because we are halving every time. That's right. So when you look at this code, what is the initial gap between low and high? Initial gap means what is the value of h minus l? It will be roughly 2 power n, because from 1 to 2 power n, how many numbers are there? 2 power n. Now this logic, every time it is halving your search space. So every time it is splitting your search space into half of what it was. Okay. So to start with, if your search space was of 2 power n, it then becomes 2 power n minus 1, and then becomes 2 power n minus 2. And if you look at our termination condition, when do we terminate? We terminate when L and H are same. When L and H are same, the search space will be of size 1. Now, in order to go from 2 power n to 1, how many iterations will be there? If you are dividing something by 2, how many iterations will be there? It will be log of this quantity base 2. So this is going to be log of 2 power n base 2. And how much is this? How much is this equal to? This is equal to n. So if you know a little bit of logarithm, this is how it works. Log of 2 power n base 2, this n can go and reside here, and log 2 base 2 is nothing but 1 only. Correct? So the time complexity is order of n. And what was this n? This n was a very small quantity. It was actually representing the sequence number which we were talking about, whether it was the first sequence or second sequence or third sequence or whatever, right? So yeah, it's a pretty fast algorithm. Those of you who are saying log, it's not log of n, it's log of 2 power n. It's log of the length of the string, right? And length of the string is not n, length of the string is 2 power n. So log of 2 power n base 2 takes you back to order of n, which exactly is your answer. Does that make sense? How many of you perfectly understand the time complexity, as in why it is order of n? Yeah. I'm not sure. I have not looked at the editorial solutions and all. If you guys have looked at it, or if you are able to come up with some other solution, do share. Okay. But yeah, this is also one observation-based solution. I'm pretty sure that whatever other solution you would have the same complexity as this. Okay. All bits start from 0. Rachit is saying he's suggesting a solution. All bits start from 0. Suppose I have been given a k. K would emanate from math.ceil of k by 2. If k was even, digit would toggle. If k was odd, digit would not toggle. I can do repeated division of this by 2. Did you submit the solution? See, you have a solution. Now the next thing, even if your solution is right or wrong, the next thing that you should do is you should try to prove why your solution is right or why your solution is wrong. Usually with problems like these, where you have some sort of pattern and you have a very short code written by that pattern, people take that pattern for granted. They feel like, yeah, because this pattern is true, they first assume that this pattern is true, and then after that they go ahead and code everything. The real thing is to understand why that pattern is true. The approach that we took here was to first confront it, that is there a pattern or not. And for that we did all this circus that, yeah, every string is a representation of 0. So the left half will represent 0 and right half will represent 1. And from there we deduced all these things and put it up as code. So if you have this approach, the next thing I would want you to do is try to logically prove the correctness of your approach, that why it is correct. Like here I gave you my approach and I gave you the logical proof of it, right? I want all of you to do that to your approaches also, and then code your solution and then see what happens. So spend some time doing that. It will be a great exercise, because that is eventually what the problem solving is. And feel free, like once you submit your solution and you have some clarity over why your solution is right or wrong, comment below the video. You can just put in your code, put in your pseudocode or logic, whatever you want. Whenever I get time, I'll take a look at it and I'll take the discussion ahead. I'll give my feedbacks on it. Yeah, great, isn't it? So cool, let's meet again tomorrow, probably with some other variety of question. Yeah, okay then, bye everyone, good night.